It's October 10th, 2024. I'm out on Fraser Point on Santa Cruz Island, kind of looking to the, really to the south, maybe southeast a bit. You can see on the skyline, the volcanic ridge that goes along the north end of the island. And we're looking at these wave-cut bench, terrace deposits, Relic sea cliff here at this point. If you come out here, this is one of the better locations to see some of the evidence for the last interglacial. So I'm going to move in a little bit closer, but first I just want to point out, up on the skyline that I'm looking at, there's a little rise in there. You can kind of see it. If I move over here, there's like a little marker up there that you can see. It's on above the rise a bit. And it's just below the skyline that the slope goes up a bit. That's a Relic sea cliff, and that's as far as sea advanced in the last interglacial. So about 120,000 years ago, that little rise in the topography was a sea cliff. And then if we move in a little bit closer, we can see the deposits that underlie this flat surface, the flattish surface that is on this side of that Relic sea cliff. And let's see, I laid some books and stuff over here. And kind of around. So all this material down below, this is the Santa Cruz Island volcanics. And it's the bedrock, so it's pretty close to the surface all through here. It's this mostly an andesitic, looks like an andesitic breccia or something like this. But above that, there's a sharp contact, and I'll point at that. That's like right through here. And just above that, you see all these little fossils and stuff. So that's the marine terrace deposit. And as the sea level, well, either advanced, but more likely as it regressed and went down after the last interglacial, it left a thin veneer of marine deposits. And of course, this is very shallow marine. I mean, it's filled with stuff you can find along the beach today. And my map case, that little brown leather case, that's right at the contact now between the bedrock, the older volcanics, and this it's got to be a little bit younger than 120,000 years if it's where it receded, that marine deposit. And then above that, kind of go into more alluvial fan deposits that make up the rest of this sequence here. So this surface that we're looking at here, this is what's called the wave-cut bench. In other words, the contact between where the bedrock, the volcanics are eroded off, going under my book there, and below the shell-rich terrace deposit. And today, that's going on right out here. We know that in this little bay, this is called Forney's Cove too, kind of on the south side of Fraser Point, and it's very shallow out there. If you swim out there, or boats come in here, and it's only about 15-20 feet of water out there for some distance. So what's happening today is that's the currents, wave action, they're forming an extensive surface below the sea level that's extending out there a ways, and that's our modern wave-cut bench, extending from the sea cliff, the modern sea cliff here, and then out, most of it's underwater. And so if sea level were to drop again, this would be exposed as one of these flattish surfaces like we're seeing out towards Fraser Point. That's actually an older one, that flattish surface there. That's older than the USGS map, that is. Slightly older than the stuff that we're seeing here. So it'd be older than 120,000 years, but no exact date on that.